do the test for improvement for this third transportation table, beginning with this vacant cell XA. For the vacant cell XA, we trace a closed path starting with horizontal movement, and we cannot move horizontally to the left because this supplier X. So from this vacant cell, we move horizontally to the right, and we do not move up to this cell because it is vacant. We move from this vacant cell XA horizontally to the right up to 78. And for that horizontal movement to the right, the associated cost is the positive of this sub cost, or plus 10. After this horizontal movement to the right, the next move is vertical. And we cannot move upward because this is the demand of customer B. From 78, we move vertically downward, but not to this cell because it is vacant or empty. So from 78, we move vertically downward to 46. And the cost associated with that vertical movement downward to 46 from 78 is the negative of this cell cost, or minus 7. From 46, we now move horizontal, and we cannot move horizontally to the left because this is empty cell or vacant cell. Hence, from 46, we move horizontally to the right up to 89. And the cost associated with this horizontal movement to the right is the positive of this cell cost, or plus 12. We are now in this vacant cell, in this cell with 89 units, and from this cell we move vertical. We cannot move upward because it is vacant or empty. Thus, from 89, we move vertically downward to 6. And the cost associated with this vertical movement downward is the negative of this cell cost, or minus 8. And from this occupied cell, we move horizontally. We cannot move horizontally to the right because this is the number of units available in supplier C. So from from 6, we move horizontally to the left. Up to 87, we skip this cell because it is vacant or empty. From 6, we move directly to 87. And the cost associated with that movement is the positive of this cell cost, or plus 13. And from 87, we move back straight to the vacant cell XA. We skip this vacant cell. From 87, we go direct to this vacant cell. And we are back to where we started, the vacant cell XA. The cost associated with this vertical movement from 87 and back to the vacant cell XA is minus 6. Again, the closed path for the vacant cell XA is horizontal to the right, vertically downward to 46, horizontally to the right to 89, vertically downward to 6, horizontally to the left to 87, and vertically upward back to the vacant cell XA. We now compute the net cell cost for this vacant cell XA. We have 10 minus 7 is 3, plus 12 is 15, minus 8 is 7, plus 13 is 20, minus 6 is 14. The positive cell cost of 14, the positive net cell cost of 14 for the vacant cell XA means that if you transfer some units to this vacant cell XA, The transportation cost of 2,410 for the third distribution plan will increase by 14 pesos per unit. Thus, we will not transfer any units to this vacant cell XC. We now consider this vacant cell XC. We trace a closed path from this vacant cell used by beginning with horizontal movement to the left. We cannot move to the right because this is the number of units available in supplier X. So from this vacant cell, we move horizontally to the left, but not up to this cell because it is vacant cell. Hence, from this vacant cell, we move horizontally to the left to 78. And for that horizontal movement, the cost associated for that horizontal movement is the positive or plus 9. After this horizontal movement to the left, the next move is vertical. And we cannot move upward because 124 is the demand of customer B. So from 7 to 8, we move vertically downward, but not up to this cell because it is vacant. From 7 to 8, we move vertically downward to 46, and the cost associated with that vertical movement downward is the negative of this cell cost, or minus 7. After this vertical movement, the next move is horizontal. If you move horizontally to the left, it's vacant, so we will not do that. And we move horizontally to the right from 46 to 89. And the cost associated with that horizontal movement to the right from 46 to 89 is the positive or plus 12. And from 89, the next move is vertical. If you move vertically downward, you can do that because this is occupied. But the next move is horizontal, and this is vacant. If you move horizontally to the left up to 87, you can do that. But the next move is vertical, it's vacant, and it's vacant. So if you move from 89 vertically downward to 6, you will not be able to go back to this vacant cell XC. Hence, from 89, you move vertically upward, and you are back to where you started, the vacant cell XC. And the cost associated with the vertical movement upward from 89 and back to this vacant cell XC is the is the negative of this cell cost, or minus 8. Again, the closed path for the vacant cell XC is horizontal to the left, vertical downward to 46, horizontal to the right to 89, and vertical upward back to the vacant cell XC. We compute the net cell cost for this vacant cell. We have 9 minus 7 is 2, plus 12 is 14, minus 8 is 6. The net cell cost of positive 6 for the vacant cell XC means that if you transfer some units to this vacant cell XC, the transportation cost for the third distribution plan of 2,410 will increase by 6 pesos per unit that you transfer to this vacant cell XC. Hence, we will not transfer any units to the vacant cell XC and to the vacant cell XA. Now, this vacant cell YA, we create a closed path. We trace a closed path for this vacant cell YA, beginning with horizontal movement, and we cannot move to the left because this is supplier Y. We move horizontally to the right. If you move up to 46 only, the next move is vertical. You cannot move downward because it's vacant. You can move upward, but the next move is horizontal, either to the right, or to the left. And both horizontal movements will land you at a vacant cell. So from this vacant cell YA, we move horizontally to the right, straight to 89. We skip this occupied cell. From this vacant cell YA, we move horizontally to the right to this cell 89 with 89 units. And the cost associated with that horizontal movement is the positive of this cell cost, or 9. After the first horizontal movement, the next move is vertical. You cannot move upward because it is vacant cell or empty cell. Hence, from 89, we move vertically downward to 6. And the cost associated with that vertical movement downward is the negative of this cell cost, or minus 8. After this vertical movement, the next move is horizontal. You cannot move to the right because this the number of units available in supplier C. From 6, we move horizontally to the left. We cannot move up to here because it is vacant cell. Thus, from 6, we move straight to 87. We skip this unoccupied cell or vacant cell. From 6, we move horizontally to the left to 87. And the cost associated with that horizontal movement to the left is the positive of this cell cost. The cost at this cell where we started, plus 13. And after this horizontal movement to the left, the next move is vertical. And we move vertically upward back to this vacant cell where we started, the vacant cell YA. The cost associated with this vertical movement upward back to this vacant cell YA is the negative of this cell cost, 6 or minus 6. Again, the closed path for the vacant cell YA is horizontal to the right up to 89, vertical downward 6, and horizontal to the left up to 87, and vertical upward back to the vacant cell YA. We calculate the net cell cost for the vacant cell YA. We have 9 minus 8 is 1, plus 13 is 14, minus 6 is 8. As with the vacant cells XA and XC, we will not transfer any units to the vacant cell YA because the transportation cost of 2,410 will increase by 8 pesos per unit that we will transfer to the vacant cell YA. The last vacant cell to consider is this vacant cell ZB. And we trace a closed path for this vacant cell beginning with horizontal movement. If we move horizontally to the left from here to 87, the next move is vertical. And this is empty and this is empty. So we cannot move vertically upward. So from this vacant cell, we move horizontally to the right up to 6, and the cost associated with that horizontal movement to the right is the positive of this cell cost, or positive 11. After the first horizontal movement to the right, the next move is vertical. And we cannot move to this cell because it is vacant. We move from 6 to 89. For this vertical movement upward, the cost associated is the negative of this cell cost, or minus 13. After this vertical movement upward, the next move is horizontal. And we cannot move to the right because 135 is the number of units available in supplier Y. From 89, we move horizontally to the left, but not to this cell because it is vacant or empty. From 89, we move horizontally to the left up to 46. And the cost associated with this horizontal movement to the left is the positive of this cell cost, 8. And we write here plus 8. After this horizontal movement to the left, the next move is vertical. If you move vertically upward, you can do that because this is occupied. But the next move is horizontal, either to the right or to the left. But in both of these horizontal movements to the right or to the left, you will land at vacant cell. So you cannot move vertically upward to 78. And so you take the vertical movement downward and you are back at the vacant cell CB. From 46, you move vertically downward back to where you started, the vacant cell CB, and the cost associated with that vertical movement downward is the negative of this cost, or minus 12. Again, the close spot for this vacant cell CB is horizontal to the right, 6, vertical upward to 83, horizontal to the left, and vertically downward back to the vacant cell CB. We compute the net cell cost for this vacant cell. We have 11 minus 13 is negative 2. Negative 2 plus 8 is 6. 6 minus 12 is negative 6. So there is only one vacant cell with negative net cell cost. That means that we will transfer some units to the vacant cell CB. And if we transfer some units to the vacant cell CB, the transportation cost of 2,410 will decrease by 6 pesos per unit that we transferred to the vacant cell CB. So now we know that we have to construct the fourth transportation table because we still have a negative net cell cost in the test for improvement for the third transportation table. And I will write again the close spot for the vacant cell CB to determine how many units are to be transferred to this vacant cell CB. This is the close spot for the vacant cell CB, where we will transfer some units. And to determine the number of units to be transferred to this vacant cell CB, we consider the vertical directions in the closed path. Vertically upward, we started from 6. And vertically downward, we started from 46. Hence, the number of units to be transferred to the vacant cell CB is between 6 and 46. Now, all the numbers in the occupied cells that are not in the closed spot for the vacant cell CB will remain the same in the fourth transportation table. These are 78. 78 is not in the closed spot. So 78 will remain 78 in the cell CB in the fourth transportation table. XB 78 will remain 78. XB 78. And it's the same with 87. 87 is not in the closed spot, not within the closed spot for the vacant cell CB. Hence, 87 will remain as is for the cell CA in the fourth transportation table, CA 87. Now, which of these two between 46 and 6 is to be transferred to this vacant cell CB? If you transfer 46 here, 46 plus 87 will be more than 93. Thus, we cannot transfer all of 46 to this vacant cell CB. If we transfer 6 to this vacant cell, we have 87 plus 6 is 93. And then we have to change, if we transfer 6 here, we have to change 46, 89. And if we transfer 6 here, this cell will have no units. Or this cell C will be vacant cell in the fourth transportation table. We move 6 units to this vacant cell CB in the fourth transportation table. CB6. And this 46 will change the number of units to be placed in this cell to replace 46. Cell YB is equal to 124 minus 78 minus 6, or 124 minus 84. The number of units to replace 46 in the cell XB is 40. So we write YB is 40. Is this correct? 12 minus 8 is 40. And 89 will also change. The number to be placed here in this cell YC is 135 minus 40. One 35 minus 40 is 95. So 89 now will change to 95 for the cell YC in the fourth transportation table. YC is 95. And this cell ZC will now be 0 or vacant or empty because we transferred 6 units in this vacant cell CB. Now we check if we have still a balanced transportation table. Add the numbers vertically. 0 plus 87 should be equal to the demand of A. 78 plus 40 plus 6 is 124. 0 plus 95 plus 0 is 95. Also add the numbers horizontally. 0 plus 78 plus 0 is 78. 0 plus 40 plus 95 is 135. 87 plus 6 plus 0 is 93. So this is the fourth transportation table from which we will now develop the fourth distribution plan. Develop the fourth distribution plan corresponding to this fourth transportation table. Fourth distribution plan, in the first column we have supplier followed by demand. The number of units to be transported or transferred from supplier to the customer, and the cost per transportation cost per unit, and the total cost of transportation. We start with supplier X to customer B. We transfer 78 units at 7 pesos per unit. From customer X to from supplier X to customer B, we transfer 78 units at 7 pesos per unit. And the total cost of transporting 78 units at 7 pesos per unit from supplier X to customer B is 78 multiplied by 7 equals 546. From supplier Y to customer B, we supply 40 units at 12 pesos per unit. From supplier Y to customer B, we supply 40 units and the transportation cost per unit is 12 pesos. So the total cost of transporting 40 units from supplier Y to customer B at transportation cost of 12 pesos per unit is 40 multiplied by 12 equals 480. From supplier Y again, we supply 95 units to customer C at transportation cost of 8 pesos per unit. From supplier Y to C, we supply 95 units. Transportation cost per unit is 8 pesos. The total transportation cost of supplying 95 units from supplier Y to customer C at transportation cost of 8 pesos per unit is 95 multiplied by 8 equals 760 pesos. And from supplier C, we supply 87 units to customer A at transportation cost of 6 pesos per unit. From supplier C to customer A, 87 units at 6 pesos per unit. And the total transportation cost is 87 multiplied by 6 equals 522. Finally, from supplier C, we supply 6 units to customer B at 11 pesos per unit. From supplier C to customer B, we supply 6 units at transportation cost per unit of 11 pesos for a total transportation cost of 6 multiplied by 11 equals 66 pesos. And we add the last column to get the total transportation cost for the fourth distribution plan. We have 546 plus 480 plus 760 plus 522 plus 66 equals 2,374 pesos. Now you can see that the transportation cost of 2,410 corresponding to the third transportation table decreased to 2,374 pesos. The total transportation cost corresponding to the fourth transportation table. Now we check if this 2,374 pesos is correct. Checking. The old transportation cost is the transportation cost from the previous table, from the third transportation plan, 2,410, from which we subtract the total decrease in transportation cost. The total decrease is the number of units transferred multiplied by the decrease in transportation cost per unit. And we transferred 6 units to the vacant cell ZB, and the decrease from the test for improvement, we found that the decrease in total transportation cost per unit is 6 pesos per unit if we transfer some units to the vacant cell ZA. Thus, the total decrease in transportation cost is the number of units transferred to the vacant cell CB, 6 units multiplied by the net cell cost of the vacant cell CB, negative 6. 6 multiplied by negative 6 is negative 36. 2,410 minus the total decrease in transportation cost by transferring 6 units to the vacant cell CB minus 36 equals 2,374, which is our transportation cost for the fourth distribution plan. So this total transportation cost corresponding to the fourth transportation table is correct. The next step is to do again the test for improvement if we can still decrease or lower this transportation cost of 2,374. And for the test for improvement, we consider again the vacant cells. For the fourth transportation table, these are the vacant cells XA, XC, YA, and ZC. We start with the vacant cell XA. We trace a closed path beginning with horizontal movement, and we cannot move horizontally to the left because this is the supplier X. Hence, we move horizontally to the right to 78. And the cost associated for that horizontal movement to the right is the positive of this cell cost, or 10. After that horizontal movement to the right, we move vertically downward. If we move to vertically downward to 40, the next move is horizontal. And you cannot move to this vacant cell because it's empty. If you move to 95, you can do that, but the next move is vertical. Downward, it's empty, and upward, it's empty. So from 7 to 8, we move straight to 6, vertically downward to 6, we skip this occupied cell. From 7 to 8, we move to 6, and the cost associated with that vertical movement downward is the negative of this cell cost, or minus 7. After that vertical movement downward, we move horizontally. And we cannot move horizontally to the right because this vacant cell. So we move horizontally to the left to 87. And for this horizontal movement to the left, the cost is the positive of this cell cost, or plus 11. And after this horizontal movement to the left, the next move is vertical. And you cannot move to this cell because it's empty. So from 87, you move vertically upward straight to where you started, the vacant cell XA. From 87, you move straight to this vacant cell XA, our point of origin. And the cost associated with that vertical movement upward from 87 and back to this vacant cell is the negative of this cell cost. And we write here minus 6. Again, the closed path for this vacant cell XA is horizontal to the right, vertically downward to 6, horizontal to the left 87, and vertically upward from 87 straight to the vacant cell XA. We compute the net cell cost for the vacant cell XA. We have 10 minus 7 is 3, plus 11 is 14. 14 minus 6 is 8. And this positive net cell cost of 8 means that if you transfer some units to the vacant cell XA, the transportation cost of 2,374 will increase. Thus, we will not transfer any units to the vacant cell XA. And if you get all positive net cell costs for all the vacant cells, that means that you have obtained the minimum total transportation cost. But if we get at least one negative net cell cost in this test for improvement, that means that there is still a fifth transportation table. Now we check if we have a negative or positive or zero net cell cost for the vacant cell XC. For the vacant cell XC, we trace a closed path beginning with horizontal movement, and we cannot move to the right because this is the number of supplies, the number of units in supplier X. So from this vacant cell, we move horizontally to the left, and we cannot move up to this cell because it is vacant or empty. From this vacant cell, we move horizontally up to 78. And the cost for that horizontal movement to the left, from here to here, is the positive of this cell cost, 9. After this horizontal movement to the left, the next move is vertical movement, and we cannot move upward because this is the demand of customer B. Hence, from 7 to 8, we move vertically downward. If you move up to 6, you can do that, but the next move is horizontal. If you move to the right, it's vacant. If you move to the left, you can do that, but the next move is vertical. And this is empty, and this is empty. And you will not be able to go back to your point of origin, the vacant cell XC. Hence, from 7 to 8, we move up to 40 only. From 7 to 8, we move vertically downward up to 40. And the cost associated with that vertical movement downward is the negative of this cell cost, or minus 7. And after this vertical movement downward from 7 to 8 to 40, the next move is horizontal. And we cannot move horizontally to the left because this is vacant cell. We move horizontally to the right. And for that horizontal movement to the right, the cost is positive 12. After that horizontal movement to the right, the next move is vertical. If you move vertically downward, you cannot do that because this is empty. But you can move vertically upward because you will be back to your point of origin, the vacant cell XC. Hence, from 95, we move vertically upward and we are back at our point of origin, the vacant cell XC. And the cost associated with that vertical movement upward is the negative of this cell cost. And here we write minus 8. Again, the closed path for this vacant cell is horizontal to the left up to 7 to 8, vertically downward up to 40 only, and horizontally to the right to 95, and finally vertically upward, and you are back at the vacant cell XC. You find the net cell cost for this vacant cell. You have 9 minus 7 is 2, plus 12 is 14, minus 8 is 6. And we will not transfer any units to the vacant cell XC because that will give us an increase of 6 pesos per unit that we transfer to the vacant cell XC. Now, we consider the vacant cell YA, and we trace a closed path for this vacant cell, beginning with horizontal movement. If you move horizontally to the right up to 95, the next move is vertical. Vertically upward, it's vacant. Vertically downward, it's vacant. Hence, from this vacant cell YA, you move horizontally to the right up to 40 only. And the cost associated with that horizontal movement to the right is the positive of this cell cost, or plus 9. And after that horizontal movement to the right, the next move is vertical. If you move vertically upward, you can do that to 78, but the next move is horizontal, either to the left or to the right. But in both horizontal movements to the left and to the right, you will end up at a vacant cell. Hence, from 40, you move vertically downward up to 6. And the cost associated with that vertical movement downward from 40 to 6 is the negative of this cell cost. And we write here minus 12. After this vertical movement downward, we move horizontally, but not to the right because this is a vacant cell. We move horizontally to the left up to 87. And for that horizontal movement to the left, the cost associated is the positive of this cell cost. And in here we write plus 11. And after this horizontal movement to the left, we move vertically upward. Not up to this cell because it is vacant, but up to this cell where we started, the vacant cell YA. And the cost associated for this vertical movement upward is the positive of this cell cost, or plus 6. Again, the closed path for the vacant cell YA, horizontally to the right to 40, vertically downward to 6, horizontally to the left, and vertically upward back to where we started, the vacant cell YA. And we find the net cell cost for this vacant cell. We have 9 minus 12 is minus 3 plus 11 is 8. Sorry, this should be minus 6. Because we have 9 minus 12 plus 11 minus 6. And the net sum cost is 9 minus 12 is minus 3 plus 11 is 8 and 8 minus 6 is 2. And the positive net sum cost of 2 means that the transportation cost of 2,374 pesos will increase for each unit that you will transfer to this vacant cell YA. Hence, we will not transfer any units to this vacant cell YA because our transportation costs will increase. Finally, the vacant cell ZC. This is the vacant cell ZC, and we trace a close path for this vacant cell. Beginning with horizontal movement, and we cannot move horizontally to the right because this is the number of units in the supply of supplier Z. And so from this vacant cell, we move horizontally to the left. If you move up to 87, the next move is vertical, upward, and you have 2 vacant cells above 87. So we cannot move up to 87. From this vacant cell, we move horizontally to the left up to 6 only. And the cost associated for this horizontal movement to the left is the positive of this side cost. After this horizontal movement to the left, the next move is vertical. And do not move up to 78 because the next move is horizontal. If you move horizontally to the right, you have vacant cell. If you move horizontally to the left, you also have vacant cell. Hence, from 6, you move vertically upward up to 40 only. And the cost associated with the vertical movement upward is the negative of this side cost. And we write here minus 11. After this vertical movement upward, the next move is horizontal. And we do not move horizontally to the left because it's vacant cell. This is a vacant cell. Hence, from 40, we move horizontally to the right up to 95. And the cost associated with this horizontal movement to the right is the positive of this cell cost 12. And here we write plus 12. And next to this horizontal movement to the right is a vertical movement. And do not move vertically upward because you will end up at the vacant cell. So from 95, move move vertically downward, and you are back to where you started, the vacant cell C, Z, C. And for this vertical movement downward from 95 back to this vacant cell, the cost is the negative of this cell cost. And we write here minus 8. Again, the close path for this vacant cell is horizontally to the left up to 6, vertically upward up to 40, horizontally to the right to 95, and vertically downward back to the vacant cell ZC. We find the net cell cost for this vacant cell. We have 13 minus 12 is 2, plus 12 is 14, minus 8 is 6. If you transfer some units to the vacant cell ZC, the transportation cost, the most recent transportation cost of 2,374 pesos will increase by 6 pesos for each unit that you will transfer to this vacant cell. Now, all the net cell costs for all the vacant cells in the fourth transportation table are positive. And this means that we have obtained the minimum transportation cost. The minimum transportation cost now is the fourth transportation cost, which is 2,374. And this will be the minimum total transportation cost. And the fourth distribution plan from which this minimum total transportation cost was obtained will be called the optimal distribution plan. This is the optimal distribution plan. The optimal distribution plan is the last distribution plan after the before the last test for improvement in which all the net sell costs are positive. Again, the optimal distribution plan is the distribution plan before the last test for improvement in which we obtained all positive net sell costs. So this optimal distribution plan is exactly the same as the fourth distribution plan. For the optimal distribution plan, you simply write again the fourth distribution plan, but instead of writing fourth distribution plan, you write optimal distribution plan. And everything in the table is the same except the last entry. In the fourth distribution plan, we write here fourth transportation cost. For the optimal distribution plan, you write minimum transportation cost. The fourth transportation cost is 2,374 pesos, and that is also your minimum transportation cost. And we declare that this is the minimum transportation cost because in the last test for improvement, we obtained all positive net sell cost. And in the optimal distribution plan, these are the supplies to be obtained from these suppliers to be distributed to these customers. And these are the corresponding transportation costs from supplier to customer. And the total of the last column is the minimum transportation cost. For your practice, consider again this exercise. This exercise, I have already given this to you in the preceding two lessons. In the first exercise, in which you have the same transportation table given, I asked you to develop the initial transportation plan. And in the second exercise, with the same transportation table, I asked you to do the test for improvement based on the initial transportation table, and to develop the second transportation table, from which I also asked you to develop the second distribution plan. Now for this exercise, you still have the same transportation table, but you will now do the test for improvement based or using the second transportation table. And from the test for improvement, you proceed to complete the solution until you obtain the minimum transportation cost. In the final answer should be given as optimal distribution plan. And the transportation cost at the bottom should be written as minimum transportation cost. Again, the optimal distribution plan is the same as the last distribution plan before the test for improvement, in which you get all positive net sell cost. If you have question about this lesson, you ask your question in the comments below. And in the next lesson, we will start with the first case of unbalanced transportation problem, where the total demand is more than the total supply. If you have question again, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Calison, the channel of learning and leisure. Or you may ask your friends, your classmates, neighbors, and relatives to subscribe to my YouTube channel, Art Calison. Thank you for joining me in my class today in Mathematics in the Modern World.